Hi, welcome to the Unit 3 test review. In this problem, they're asking you to find, for each pair of angles, name the transversal and the special angle pair. If you don't remember what these special angle pair names are, let me put this summary here for you. We have corresponding, which are the angles on the same location of each intersection, so they're either both on the top right or both on the bottom left, but they're both on the same location. Alternate interior, which is on the inside space between the parallel lines, so they're like trapped between the two parallel lines. These are the parallel lines. So the angles are trapped in there, one on each side of the transversal. Alternate exterior on the outside of the parallel lines, one on each side of the transversal. Consecutive interior are on the inside space between the parallel lines, but they're on the same side of the transversal. Vertical angles are both sitting on the same intersection. Notice that this bottom intersection does not include any angles when we talk about a vertical angle pair. Both angles are on the same intersection and they are across from each other, just like a bow tie. Linear pair are also on the same intersection. Notice that this bottom intersection is not being used to describe a linear pair. They're both on the same intersection, one sitting right next to the other. So let's start looking at these angles. Angle 1 and angle 7. So we're going to mark them here, angle 1 and angle 7, which means that this part of the drawing is not being used right now. I can identify the transversal as the line, the only line left that has two intersections, 1 and 2. So the transversal here must be line K. And I can see that both angles are on the outside space. See, this is inside between the lines. They're on the outside space of the lines, one on each side of the transversal. So that makes them alternate exterior. You have to reset your drawing to do the next problem. So you erase everything. Go to the next one. 8 and 9. Here's angle 8. Here's angle 9, which means we're not using this part of the drawing. And I can see in this case the transversal line L would be the only line that does have two intersections. So we call the transversal line L. And I can see that both of these angles are on the inside space trapped between the other two lines, but they're on the same side of the transversal. So that would make them consecutive interior. Reset the drawing for the next one. Angles 4 and 11. Here's 4. Here's 11, which means we're not using this side of the drawing. And I can see that the transversal is line M. M is the only one that touches two lines. So here's line M. And I can see that on this top intersection, angle 4 is the bottom left angle. And in this intersection, angle 11 is the bottom left. So they're both sitting in the same location of each intersection, so I would call them corresponding angles. Resetting the drawing here. The next one is angles 5 and 3. So I'm not using this bottom part of the drawing. I can see that the transversal is line K. It's the only line there that crosses two intersections. And these angles are sitting on opposite sides, on alternate sides of the transversal and on the inside, so they are called alternate interior angles. Lastly, we have angle 7 right here and angle 11 down here. So I'm not using this part of the drawing. And they look to me that if I stand at the center of each intersection, they're both on the right bottom of the intersection. See, on the right bottom. So I would call angle 7 and angle 11 corresponding angles. And the transversal, forgot to write that first, is line L. Now they're asking you to name a pair of vertical angles. There are many options for vertical angles. For example, 9 and 11 are a pair of vertical angles. Also 1 and 3 are a pair. Also 5 and 7. There's so many options. You just choose one. How about we choose 8 and 6? Angle 8 and angle 6. Now they're asking you to find a linear pair. Many linear pairs. For example, 9 and 12 form a linear pair here. So do 11 and 10. So do 8 and 7. So do 6 and 5. So on and so forth. So let's pick from this intersection angle 1 and angle 4 can be chosen. Or even if you wanted to, you could have chosen angle 1 and angle 2. They're all linear pairs. Moving on to the next problem. Name each type of angle relation. Here I can see that both angles marked are on the inside of the parallel lines on alternate sides of the transversal. So I am going to call those alternate interior angles. Next, the 60 and the 120, I can see that they're on the same side of the transversal, but trapped on the inside space between the parallel lines. So they're consecutive interior. Here the angles are on alternate sides of the transversal, but on the outside space, outside of the parallel lines, so they're alternate exterior. And lastly, we have two angles that correspond in the same location of each intersection. They're both on the top right, so they are corresponding angles. In the next problem, they're asking us to solve for x and find the measure of angle ABC. This part's very important. It means that our problem has two parts. We need to make sure we do both parts. In the first part that we need to solve for x, remember those steps that we discussed in class? These are the steps we had seen in class. Number 1, what kind of special angle pair are they? Well, if I see this angle and this other angle, I can identify them as alternate interior. Step number 2, what do I know about that special pair? Well, I should remember that alternate interior are equal to each other. And step number 3, set up the equation based on what you just wrote, that this should equal that, and solve. So let's write that equation. 3x plus 30 should equal 5x minus 40, because we know that alternate interior angles should equal each other. We're going to solve this. So I'm going to put all my x's on the left-hand side here. So I'm going to, anything that does not have an x here, I cancel it out. So I do minus 30 on one side, and when I do on one side, I do on the other. And I bring down my 3x is equal to 5x minus 70. Of course, this is then the side that should not have any x's. So then this 5x does not belong here. Cancel this side out. 3x minus 5x should have a negative 2x. And you still have a negative 70 on this side. Keep in mind that this 70 was negative because it had a subtract symbol right there. So you need to still bring that negative down. And the last step is to divide both sides by the coefficient of x. Whatever number is stuck to the x, that's the number you're going to divide by. And these cancel out, and you have x should equal to 35, and that's the answer that you write here, 35. Now, remember that you're not done. You still need to find the measure of angle ABC. So we need to find angle ABC. Here's dot A, here's dot B, here's dot C. So they must be talking about this angle right here. So we need to find out what is 3x plus 30. Well, thankfully, we just found out what x is, so we can substitute it in there. We know that it's really 3 times 35 plus 30. and that produces the number 135. So the measure of angle ABC is 135 degrees. Let's move on to the next problem. They're asking you to find x, y, and z. Now notice that there's a bunch of angles shown here, but we're only going to work with 2 at a time. Remember that we need to identify 3 steps to work these problems, the same ones as the previous problem, and we're going to pick 2 of the angles to work with at a time. For each pair that we select to work with at a time, I'm going to identify what kind of special angle pair they are, then what do I know about that special angle pair, and then set up the equation based on that and solve. So I want to solve for x first, so I'm going to pair up this angle that has the x with something that I know I can work with. For example, this 110 right here. I know, step number 1, what kind of special pair they are. Well, these are vertical angles. Step number 2, what do I know about that special pair angle? Well, I should know that vertical angles are congruent. So step 3, I'm going to set up the equation. 4x minus 10 should equal 110, and I solve for that. I'm just going to add 10 here to both sides. And you have 4x is equal to 110 plus 10 is 120. And then the last step is to divide by the coefficient of x. Divide both sides by 4. And you're going to have that x is equal to 30. So this answer is what you write up here for x. Now you're going to reset your drawing here, erase these little markings, because you're going to work with something that has a y. That's what we're looking for now. Let's find an angle that has a y, and I find it right here. And I want to try to pair up that angle with another angle easy to work with that I know has a special relationship to this one. If these 2 lines are parallel and I cross over to the other side of the transversal and the other intersection, I find the 110 again. And I can see that this 110 is an alternate interior angle to this one. So I can work with that pair. And then in step number 2, what do I know about alternate interior angles? Oh, I should know that they are equal, they're congruent. So I'm going to set up that equation. 3y plus 20 should equal 110. And I'm going to solve for that. Subtract 20 from both sides here. And then 3y is equal to, now you have 110 minus 20. You get the number 90. And the last step is to divide by the number that's stuck to the variable, the coefficient of y. So we divide by the coefficient of y. Here's 3. And you have that y is also 30, just like x. So we write that answer here. Y is 30. Now we need to solve for z. And we're going to identify our angle that has z, which is right here. And I'm going to find another angle that I can work with. Now, there's nothing on the line immediately next to it. Like, for example, this 3y plus 10. It doesn't really have a special angle pair relationship with this 5z. So I'm going to skip over this line and just kind of remove it for now from my drawing and just work with this parallel line and this parallel line. Because they're all parallel, so I can just temporarily not use this part of the drawing. And so now I can see that angle 5z is a consecutive interior with this 110. They're both on the same side of the transversal, one right after the other on the same side of the transversal. Step number 2, what do I know about consecutive interior angles? Well, I should know that consecutive interior add up to 180. So that's the equation that I'm going to set up here. I should know that 5z plus the 110 should equal 180. And that's exactly what I'm going to write down to solve my equation. 5z plus 110 is equal to 180. You solve it just like the other ones. Subtract the 110 from both sides. And you're going to get that 5z is equal to 70. And then you're going to divide by the coefficient of z by the number stuck to the variable. It's called a coefficient. So you divide by 5, both sides, and you should get that z is equal to 14. That is your answer for z, and you have finished all problems in this problem 4. In the next problem, here they're asking us, they're given the measure of angle 1, which is this expression, and the measure of angle 2, which is this other expression. Find the measure of x and angle 1, and our lines j and k parallel. Well, the first thing we need to do is identify where in the drawing are these angles 1 and 2, and we can find them right here. Here's angle 1, and here's angle 2. The second thing we do is think about whether there's any special relation between these two angles. And if we remember what vertical angles look like they're formed by two intersecting lines and the angles face on opposite directions, that's exactly the situation we have here. So I would call them vertical angles. We know that vertical angles should be congruent, in other words, equal to each other. So that now should help me set up the equation that I need to solve for x. The expression that represents angle 1, which is 6x plus 20, should equal the expression that represents angle 2, because in vertical angles, these two should be the same. So that's what we're going to write. 6x plus 20 is equal to 4x plus 50. All we have to do now is solve this. I'm going to keep all my terms with x's on the left-hand side, which means this 20 that does not have an x, I'm going to cancel it out. What I do on one side, I do on the other. And 6x is equal to 4x. 50 minus 20 is a 30. Reminding myself that I want all the x terms on the left-hand side, I now take this 4x term that's on the left, cancel it out. Subtract that from both sides. 6 x's take away 4 x's. I just have 2 x's remaining. Bring down the 30. The last step is to divide by 2, and x is equal to 15. So in the first row of our answers, x equals, if this were a computer question, you would click on this box to select it as your answer, but because we're doing it here in the video, we're just going to circle our answer here. After that, they're asking us to find the measure of angle 1. So if angle 1 is equal to 6x plus 20, and I already know that x is 15, then I can substitute that value here. So angle 1 is really 6 times 15 plus 20. And from that, we're going to add a number of 110 degrees. So if you were taking this on the computer, on the row for angle 1, you would scroll over to where the other 110 and you would click that box. But right now what we're going to do is circle. So what I'm going to do is this angle 1 that I have here as my answer, I'm going to go back to my drawing and write in where that 110 is supposed to go. I'll clear all this other stuff out. And at the angle of 110 should be right here. So I'm actually going to use that number. That is 110. Now, remembering what we know about alternate interior angles, this angle should be equal to this other angle because they are alternate interior angles. That would happen if these lines are parallel. However, we see that these are not the same. 110 is not the same as 115, which would then mean that the answer to our third question, are J and K parallel? We'll have to say no, because the alternate interior angles are not the same. In problem 7, they're given us, these points are given in the problem, but they've also been plotted down here for us. So what they're saying is they want to make sure you know which point is which. And they're asking you to circle the coordinates on line SR. And here's where we stop. We look at a drawing and we say, well, I see the S, but where is R? And where is that line SR that they're supposedly talking about in this problem? Here's where you're supposed to understand that if we need to focus on line SR and the line SR is not showing, it is our job to have to figure out where that line goes and where point R goes. So that's got to be our first task in this problem. Let's see what we can know about line SR. Line SR would be perpendicular to line AB. So line AB is given. So I know that line SR is going to look something like that because it's going to be perpendicular. And I know that perpendicular form a perfect X or a cross like that. But I cannot just guess where that line should go. I need to follow the steps on how to find the perpendicular line. And the first step that we're going to do here is we're going to temporarily cover up that point S that's given because we don't need it right now. After that, I'm going to find the slope of the given line, of line AB. So you're going to pick 2 points that are on good intersections. For example, we can use A and B. And to find the slope, we do this slope triangle, the rise and the run. And I can see that my slope is going from B to A. I would go down 3, so that would be a -3. And I would go over to the right 5, so that's a +5. So the slope of line AB is the rise over run, which is equal to the rise of -3 over a +5. And when you have a negative on a fraction, that negative really applies to the whole fraction, so we just sort of set it out in the front. Alright, once we have found the slope of our given original line, we don't need these markings anymore. We can get rid of those because now we need to find the slope of line SR, which we know is going to equal the perpendicular to the slope of the line that we just found. And we know that perpendicular slopes are negative reciprocals of each other. So the negative part of that title means that we need to change the sign. So if the slope, the original slope was negative, the new perpendicular slope is going to be positive. And if the fraction being used originally was 3 over 5, then the reciprocal is going to be flipped. It's going to be 5 over 3. So that slope, +5/3, is going to be the slope that now we need to use for step 3. Use that slope to find the slope of the perpendicular line. Well, that's what we found. Slope of the perpendicular line. Step 4, uncover the point. So now we're going to draw a perpendicular line moving from the given point to the given line, following these instructions on how to move. This is the instructions for the perpendicular line. So they're telling you to move up 5. 1, 2, 3, 4, 5. Kind of run out of space here. And then right 3, because the 3 is also positive. 1, 2, 3. So you end up with a point right there. And you're thinking to yourself, well, that doesn't do me much good because I need a line that moves down that way, down towards my line. Thankfully, you should remember that a +5 over a +3 is the same thing as -5 over -3. So from my starting point, I can also try going down 5 and then left 3 and find a point there. And that line is the perpendicular to line AB, And this new point that you found down here, that would be your point R that they're talking about in the original. Now that we have the perpendicular line, we're not really done. We still need to find which points in this answer bank fall somewhere along this green line. So start finding the positions of each point to see which one works, which one doesn't. So 0.53 would be going 5 to the right and then 3 up. That point sits right here. So I would not say that's part of the points on the line. 0.66, the graph doesn't extend farther out here, but if you go 1, 2, 3, 4, 5, 6, and then 6 up, 1, 2, 3, 4, 5, 6, you actually end up in this other point that we had found. So I would say 0.66, yes, is one of the points on the line. The 0.3/5, if you use your calculator and you divide 3 by 5, you are going to get the decimal 0.6. That means that this fraction is less than 1. So if I start at my origin and start moving to the right, I don't get all the way to 1. I get somewhere before the 1, and then I have to go down 3 spots, see? Then I have to go down -3. So moving a little bit beyond halfway, but not all the way to 1. Then I go down 1, 2, 3. It looks like that point is on my line. So I'm going to select that as part of the points on my line. Point -33 would be starting at the origin, going left 3, and then up 3. That point is not on the line. 0.3 -4, you go 3 to the right and then -4 down. Obviously that's not on the line. And -3 to the left, and then a little bit more than halfway up. It's right around here. That point also is not on the line. So I would say that the only points that I would circle, include in my answer, are 3/5, -3, and 6, 6. In the next problem, they're asking you to draw a line that is draw a line through a given point P that is parallel to line A, and another line through point P that is perpendicular to A. Okay? Keep in mind that parallel means same slope, and perpendicular means negative reciprocal slope. In other words, take the slope, flip it, and change the sign. So, to find the line that is parallel, all I really need to know is figure out the slope of the given line A, and then copy that same slope from point P. Well, let's try that. Here I'm going to go 1, 2, 3, 4 down, so that's -4. And then 1, 2, 3, +3 to the right. So I would follow exactly that same pattern from point P. 1, 2, 3, 4 down, and then 1, 2, 3 to the right. And I'd use that point. After I've created that point, I don't need these temporary marks that I did here. I can draw my parallel line. Now, to draw the perpendicular line, remember that our slope for line A is -4/3. So the slope of line A was -4/3. If I want the slope of the line perpendicular to A, then I have to take this fraction and flip it over, put the 3 on top and the 4 on the bottom, and then change the sign. So now it's positive. So let's try the perpendicular line now using this slope starting from my given start point. This says to go up 3 positive, so 1, 2, 3 positive, and then 4 positive also, 1, 2, 3, 4, to end up here. Of course, we know that positive 3 over positive 4 is the same thing as negative 3 over negative 4, because two negatives cancel out to a positive. So I could have gone down 3 and then left 4 to find another point. And I can keep doing that, down 3 and left 4. That way you can have many points to help you draw your straight line. And that should be your perpendicular line. After you're done with these lines, the markings that you've done in your drawing to help you out draw the lines can be erased to make the drawings of the graph look a lot cleaner. Oops, and I forgot to put the arrowheads at the end. There we go. These are our lines. Parallel in blue, perpendicular in red. The next problem, prove that this two set of points fall on a line that's parallel with the other two sets of points, which are negative 5, 6 and negative 4, 1. They do give you a graph for you to plot these points and help you visualize the lines. But making the drawing doesn't really prove that the lines are parallel. We have to do some math to do that. We know that parallel needs to mean same slope. So I can use my slope formula, y minus y over x minus x, to figure out the slope of the first two set of points. And I can do the other two set of points in a different color to help you sort them out. I'm going to rewrite this point here so that I can have them together. I'll use the formula again for this other set of points. So let's try the first one. Slope of the first line is the y minus y, so 2 minus negative 3. And then you're going to do x minus x. So it's 2 minus 3. 2 minus 3. Keep in mind that these two negatives here turn into a positive. So you actually have 2 plus 3 is 5. 2 minus 3 is a negative 1. So we have negative 5 over 1, which is the same thing as just the number negative 5. Now let's try the slope of the second set of points. Slope of the second line. Y, which is a 6, minus y, that's a 1. Let's wait for this to work. Okay, and then we're going to have to do on the denominator the x minus the x. I'm subtracting that way to help you see it. So negative 5 minus negative 4. So here we have 6 minus 1, that is a 5. And then negative 5, these two negatives become a positive. So it's negative 5 plus 4, so that's a negative 1. And as we've seen up here, that simplifies into a negative 5. Comparing the slope of the first line and the slope of the second line, we can see that they are the same. Therefore, lines are parallel. So that helps us prove that answer. In the next problem, they are asking us to do a construction. In this problem, they are asking us to construct a line parallel to the given line using point A. And I'm going to pull out here the steps that I have. You're going to first draw a point X anywhere on the given line, and I have drawn that point right here. Anywhere on the line, I just picked that as my point. The second step, you're going to draw a line connecting points A and X. And you want to make sure that line that you draw stretches beyond that point A. So here I drew more or less that line. In step number 3, using a compass, draw an arc on point X. So you're going to be using a compass, and it's kind of hard for me to rotate the compass here, but using this compass, you're going to stand on this point that you created, and you're going to draw an arc. Without changing the opening of your compass, you're going to come over here and stand on point A and also draw the same arc. It's just going to look like that. Then you're going to, sorry, I forgot to move that step, copy the same arc onto point A. Step 5, using the compass, you measure the opening at your point X, which I just noticed the label's not showing, so I'll write it there. At point X, you're going to use your compass, and you're going to open it so that the tips of your compass measure exactly the opening of your arc. You're going to mark that same arc opening on the other arc. So I'm going to come over to this other arc and measuring from this top of the line to wherever it cuts my arc there. With my compass, I'm going to do a little mark right there. And then moving my compass out of the way, I am going to draw a line through my little mark here and through A, and extending all the way out. That line is going to be parallel to my given original line, like this. It's a little bit hard for me to do with this tool that I have. I'm trying to draw it as straight as possible. So these two lines are now parallel. This line here is parallel to this line. In the next problem, they are giving us that line P and line Q are parallel. You can go ahead on those lines and draw the symbols for parallel if you want to. And they ask you to fill out these blanks. First, when angle 6 is 170, so you come over here and you find that angle 6. You find it right here, and you can temporarily write in that number. When angle 6 is 170, they're asking you to figure out what angle 7 would be. So, just trying to do this without thinking about the relationship between the given angle and the one we need to find might be difficult. So let's think about the relation. Angle 6 and angle 7 are both on the inside space between the parallel lines, and they're on the same side of the transversal, which I'm going to label here T. So, if these two angles are sitting in that position, I would call these consecutive interior. Consecutive interior means that when I add these two angles together, I should get 180 degrees. So that's how we figure out what measure of angle 7 is. 170 plus whatever measure of angle 7 is 180. So if you subtract 170 from both sides, some people might have just done this 180 minus 170 to figure out the answer. X is 10. So that's what we put here. Measure of angle 7 will be 10 degrees. Why? Because they are consecutive. So measure of angle 6 plus measure of angle 7 is equal to 180. Now they're asking us to reset the problem, so we erase this. And they're saying now, when measure of angle 6 is 140, so now this is 140, what would be the measure of angle 1? Well, we need to think about the relation between angle 1 and angle 6. And those look to me like vertical angles. Vertical angles, we should know that they are congruent. So write this here. They are vertical. 6 should be equal to 1. Therefore, pretty straightforward to know that angle 1 should also be 140 degrees. Now they're asking us to try another scenario when angle 4 is 30. So you come over here to angle 4 right here, and that is now 30 degrees. What would be angle 5? So we need to think about the relation between angle 4 and 5. They are on the outside space of the parallel lines, and they are on alternate sides of the transversal. So I would call them alternate exterior. And we know that alternate exterior angles should also be congruent. So if angle 4 is 30, angle 5 should also be 30. The last scenario they're asking us to consider is when angle 4 is equal to 25. So I'm resetting this now to a 25. What would be the measure of angle 8? Now studying these two angles, they're both sitting together on a straight line on the same intersection. I could cover up this whole side of the drawing and it doesn't affect the relation between 8 and 4. I can see now that they are a linear pair. And for a linear pair, they should add up to 180. So if I do 180 minus 25, I should figure out what I'm trying to find here. So I get 155 degrees, and that's what angle 8 would be. In the next problem, which of the following statements could be used to prove? The first thing I want to prove is that line A is parallel to line B. So we go to each one of the options, study the relation between the two lines, and see if that can help us determine. Let's keep in mind that if we're trying to determine that line A and line B are parallel, then the relationship of angles that they give us must not use A or B as a transversal because I'm trying to prove them as the parallel lines. Okay, so here they're talking about angle 4, this option 1, and angle 5. Well, these two angles are on the same side of transversal D, and if they are consecutive exterior, which means it's the immediately after exterior angle from 5 to 4, we should know that they add up to 180, not that they're congruent. So option A is not a valid option. Then we have angle 2 and angle 3. Angle 2 and angle 3, if you cover up the part of the drawing you're not using, it looks like C is the transversal, which would make angle 2 and angle 3 alternate exterior for parallel lines A and B. So that looks like a good option. So I'm going to circle that. Because they're asking which of the following statements, there could be more than one. So we need to check every single one, not stop at the first time that you find one that works. So angle 1 and angle 4. In this case, cover up the side of the drawing you're not using. But here line A is actually the transversal. And what I'm looking for is A to be one of the parallel lines. So I'm not even going to consider that. I can see 1 and 4 are corresponding, but A is a transversal, and that's not what I'm looking for. And then the last one, angle 1 and angle 6 are supplementary. For those of you that don't remember what supplementary means they add up to 180. Remember what we had said in class? That if you see the S for supplementary, the S, it should help you remember that you can transform that S into a 180 and remind you that supplementary means they add up to 180. So let's check on angles 1 and 6. Angle 1 is here. Angle 6 is here. Once again, the right-hand side of the drawing is not being used, and once again, A is a transversal, and I don't want A to be one of the transversals, so that cannot be used to prove that A is parallel to B. For the next one, they were asking you how to prove that D is parallel to C. Following the same procedure, they're asking now if 4 and 5 are supplementary. Here's angle 4, here's angle 5. So that means I'm not using this part of the drawing, which means I'm not using line C, and that's one of the ones I'm supposed to use. So that's not an option. In the next one, they are talking about angle 1 congruent to angle 2. So here's angle 1, here's angle 2. These two angles are a linear pair, and they're not congruent. They should add to 180, but even so, they don't help me prove anything in relation to another line because both angles are surrounding the same line. So I also cannot use this option. In the next option, they are saying that 6 is congruent to 5. So here's 6, here's 5, which means I am not using this part of the drawing. And again, I'm covering up line C, which should be one of the lines that I'm trying to prove is parallel. So this option doesn't work. Let's see if it's a no solution problem or if the last option works. Angle 4 congruent to angle 1. Here's angle 4, here's angle 1, which means I'm not using this part of the drawing. And the transversal here will be A, which means angle 1 and angle 4 are corresponding angles, and we know corresponding should be congruent. That would prove that line C and line D are parallel, so I'm selecting option D for the second one. In the next option here, they're saying which angle pairs are not congruent when P is parallel to Q. Just to help you understand what they're asking you and to sort out all the angles that you've learned about. Angles that should be congruent are corresponding angles, alternate interior angles, alternate exterior angle, and vertical angles. Angles that are not congruent, because together they add up to 180, are consecutive interior angles, consecutive exterior angles, and linear pair angles. So if they're asking you which angles are not congruent, you can make a list of all the linear pairs. These can take a while. You can have 1 and 5. You can have 5 and 6. You can have 1 and 2. You can have 2 and 6. And the same thing for all other 4 pairs of the other intersection. Other angles that are not congruent, you can make a list of all the consecutive interior. So on the inside, 2 goes directly to 3 here, so 2 and 3 are consecutive interiors, as well as 6 and 7. And then consecutive exterior angles, which are the list of angles on the outside. This is an outside exterior angle. I need to find the very next outside angle, so I skip over the inside ones. So 1 and 4 are not congruent. And then 5 and the very next exterior one. So skipping over the interior ones. 5 and 8. Those should be all the pairs of angles that are not congruent. In this next problem, which of the lines are parallel? It would be the lines that have the same configuration of angles around the entire intersection. So we're going to start by figuring out those angles. In this first intersection right here, I know the vertical angles are the same, so I can make this an 89, and actually I can fill out all the vertical angles. This is also 89, this 87, connects out here. This 91 also exists here. To figure out the missing angles, we know that in linear pairs where from one side of the line to the other should be 180 degrees, to figure out the missing angle, this would be 180 minus the 89, which would be 91 degrees. And because this 91 is vertical to this one, that's 91. From 89 to figure out this angle, it's also going to be 180 minus 89. So you're going to figure out that that's a 91. 180 minus 89 is going to give you a 91 there. And then the next one, sorry, 87. To figure this one out, 180 minus 87 would be a 93. Follow the vertical angle. This is also 93. And then 180 minus 91 is 89. 89. So let's make sure these numbers show up clearly. 93 and 87. The intersections that show exactly the same pattern would be the ones that are parallel. Okay, so I'm looking at the intersections in line C and line D. They follow the same configuration, 91 and 89, 91, 89, 89, 91, 89, 91. So I can say that C is parallel to D. Some people might be confused because they look at this intersection and they see the 89 and the 91, which are the same numbers on this intersection, but they're not following the same configuration. The 91 on the top should have been on the left and the 89 on the right. And they're not. They're mirror images of each other. So A and D are not parallel. Only C and D are parallel. In this problem, two laser beams are traveling in parallel. They continue this path until they hit the mirror. So this here is the mirror, which means that here's where they were coming in and they were parallel. At which point they reflect in a new direction with the beams still parallel. So these directions are also parallel. I'm going to circle the correct answers here. If angle 1 is 47, so I'm going to come over here to angle 1 and I'm going to call that a 47 degree. Then what is the measure of angle 7? Choosing from this first row of options for angle 7. Well, what is the relation between angle 1 and angle 7? I can see them that on these two parallel lines, if this is the transversal, then 1 and 7 are consecutive interior. If they are consecutive interior, then the 47 plus whatever that measure of angle 7 is should equal 180. And we solve that, subtract 47 from both sides. And you should get x is equal to 133. Okay, so that means that the measure of angle 7 is 133 degrees. So on your selections, if you were doing this on the computer, you would click this box, but because we can't click it, we can circle it. So you can write in, now that you know that this angle is 133, you can write it in. Alright, so now they're asking you for the measure of angle 3. This one is a little bit more interesting to figure out. If I have this line here, parallel to this one, this angle 3 corresponds to this other angle. They are corresponding and they should be the same. So if I were able to figure out what this empty angle is, I would immediately know what 3 is because they are the same. So I'm going to call this angle W. I do see that angle 7 and angle W are a linear pair. So together they should add up to 180. So I come over here and 133 plus W should equal to 180. So we solve for that. and W. Now you get back to the 47 degrees that you started with. So angle W is 47. It's the same as angle 3. So I now know that angle 3 is 47 degrees. Here they're asking which two lines are perpendicular in this graph. So we need to find the slope of all the lines. So really what they're asking you to do is find the slope of each one of the given lines. To find the slope of line A, pick two good points on line A that you can see exactly where they intersect, and you do the slope triangle. Rise over run. The slope of line A, I can see that the rise is a positive 2, and the run is a positive 1, 2, 3, 4. Positive 4, and I can simplify that to a 1/2. Slope of line W, I picked 2 points on line W that I can read. So here's a good one on line W, and keep following that line until I find another one right here. And I'm going to do the rise over run triangle for this one. The rise, I can see it's 1, 2, 3 over a run of 2. And that doesn't simplify, so I'll leave it like that. Slope of line D, let's find 2 good points on line D. Here's one and here's another one. The rise over run triangle here is -1, because now I'm going down, over +1, because I'm going right. So -1 over +1, that just simplifies to a -1. And the last one we're going to try is slope of line S. Pick 2 good points on line S. Here I see one. And let's see where I find another good one. Right here. So finding that slope, I go down 2, so that 2 is negative, and then to the right 1. So that slope is -2 over 1. For us to find which lines are perpendicular, they need to have negative reciprocal slopes, which means they need to be flipped versions of each other, one positive, one negative. The only ones that I see that happening for are slopes of line A and line S. They are flipped versions of each other. One's 1/2, the other one's 2 over 1. This top one is positive, this bottom one is negative. So I would say that S is perpendicular to A. Make sure you understand all the problems that were included in this review. They will all show up in your test next class. Thanks for watching.